In this video, let us see about the series and parallel circuit. There are two types of circuit, series circuit and parallel circuit. In series circuit, all the resistance are connected in series. In parallel circuit, all the resistance are connected in parallel. Let us see about the series circuit first. The best example is the serial bulb. The same current flows through all the bulbs. Same current will flow. But the problem is that whenever there is a break or some open is there, none of the bulbs can glow because in an open circuit current cannot flow. The next one is the parallel circuit. Here the best example is a toll gate. As we know here, whenever one path is closed, I can use the next path. And if both the paths are closed, I can use a third path. So all our home appliances will be connected in parallel so that if I turn off one device, other device will not get affected. The only issue here is all the devices should have the same voltage rating. So we know all our equipments are rated for same voltage, same 230 volts. So all devices which are rated for 230 will be connected in parallel and I can use whichever device I want. So now you know the advantage of parallel circuit. Now let us see the voltage and current equations in a circuit, in a series circuit with resistance. So in this case, three resistance are connected in series and voltage V1, V2 and V3 are the voltage drops across each resistance and the total voltage, applied voltage is V and the total current is I. So in this circuit there is only one path, so only one current will flow through all the resistance. So the current is same in case of a series circuit. And the voltage V, this total voltage V gets divided into V1, V2 and V3. So the sum of the voltages will be equal to the total voltage V. So V, according to Ohm's law, V is equal to IR. So I can write I into, I is the total current, into R equivalent. R equivalent means you have three resistance. So what is the equivalent resistance of this one? R equivalent is equal to, so instead of V1 I can write I into R1, I into R2 for V2 and I into R3. So you take I as common, you will get R1 plus R2 plus R3. So R equivalent is R1 plus R2 plus R3. So in a series circuit, you can add all the resistance together to find the equivalent resistance. So I can write or minimize the circuit like this. The total applied voltage V and you have R equivalent, where R equivalent is the sum of all the resistances. And let us find the power in this circuit. It is very simple. I square R is the power. So if you want to find the power in this circuit, I square, since current is same, I am writing I square into this resistance plus I square into this resistance plus I square into this resistance R3. So simply you can add the power of each resistance and add it. So that will be the total power in the series circuit. Now we can find the voltage across the each resistance. So there is a rule for that, how this voltage gets divided among the resistance. So we know I is equal to V divided by R equivalent. So this is V and R equivalent is there. So V1 is equal to I into R1, V2 I into R2. Now V1 is equal to, instead of I am writing V divided by R equivalent into R1. Similarly, if I want to write for V2, I can write V divided by R equivalent into R2. So you can see here, if I want to find the voltage across R1, what I have to do? Take the total voltage divided by total resistance, that is the R equivalent, into, if I want V1, multiply by R1. If I want to find the voltage across V2, multiply by R2. So this is called the voltage division rule. So if you know the total voltage and total resistance, you can find what will be the voltage drop across each resistor. So voltage division rule says that if you want to find the voltage across a particular resistance, divide the total voltage by total resistance into that particular resistance. So this is voltage division rule. This is very important rule to solve the circuits, electric circuits. Let us consider an example where the resistors are connected in series. Now I want to find the voltage across each resistor and also find the total current in this circuit. So for that, I have taken the R values as 10 ohms. So all three have same 10 ohms. So R equivalent in a series circuit, we know R equivalent is sum of all the resistances. And I is equal to V divided by R equivalent. So you can find what is the total current easily. Now let us find what is the voltage across R1, R2 and R3. So what is V1? V1 is I into R1. So you will get I value is here, R1 10 ohms. So you will get 33 volts. Since all the resistance are equal, the voltage gets divided equally. So the total voltage is 100 volts. So each resistance each resistance is equal. So voltage gets divided equally. So when all the resistance are same, the voltage get divided equally. You can apply the voltage division rule directly and find it. So what is the voltage division rule? V1 is equal to total voltage, that is 100 volts, divided by total resistance, that is 30 ohms, into, if I want to find V1, I have to write R1. So it is 33 volts. So anything you can apply, any method, and find the voltage across each one. Since all the resistance are equal, the voltage gets divided equally. Now let us see another example where the resistance are different. Now let us consider another example where all the three resistance have different values. So in this case we will find the R equivalent and the total current. We can see that in the previous case the R equivalent was 30 ohms but the current was 3.3 amps. Now the current, as the resistance value has increased, the current has decreased. And apply voltage division rule to find the voltage across R1, R2 and R3. So V1 is equal to total voltage divided by equivalent resistance into that particular resistance R1. So 100 divided by 60 into 10. So this is 16 volts. So now we are getting 16.6 volts here across R1. So find V2. So the V2 comes around 33.3 volts. So here 33 volts is there, and for V3 you change the resistance value alone, so it comes around 50 volts. So here we have 50. So if you add all these three, it will come to 100 volts. So you can see one thing is here, this is 10 ohms and this is 20 and this is 30. So for 10 ohm the drop is 16.6 volts, for 20 ohms it is 33 volts. So as the resistance increases, the voltage drop increases. Two resistors when they are connected in parallel, so what will be the equivalent resistance? You can see here the voltage across each one is same, and the total current I is coming here, but you have two paths for the current to flow, so it gets divided. How it gets divided depends upon the current division rule, so that we will see. So total current I is equal to I1 plus I2. So I is V divided by R equivalent. I1 is voltage is same, so V divided by R1, and for I2 I can write V divided by R2. So here V is common, so take it. So what is R equivalent? 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So you can simplify, if you want you can simplify this one. So that becomes R equivalent is equal to R1 R2 divided by R1 plus R2. Okay. So only when you have two resistance in series, it is easy to apply this one. Otherwise you can keep this as such, because when you have 4 or 5 resistors in parallel, it is difficult to derive this one. So let us take the second case where 3 resistors are in parallel. So in this case I can write I is equal to I1, I2 and I3. Similarly, what you will get is 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if I have 5 resistance, I will write 1 by R4 plus 1 by R5 also. So you keep the equation as such. It is not a big deal. Okay. And here in parallel circuit, this conductance plays a major role. So 1 by R, we know conductance is nothing but 1 by reciprocal of resistance. So I can write conductance is equal to G1 plus G2 plus G3. Now let us find the current through each resistor. That is, we are going to find what is I1 and I2 using current division rule. So first, according to Ohm's law, V is equal to I into R equivalent, where I is the total current and R equivalent is the total resistance. So we know for a parallel circuit, R equivalent is equal to R1 R2 divided by R1 plus R2. So what is I1? I1 is the current through resistor R1. So I1 I can write it as the voltage V divided by R1. So V is I into R equivalent, so divided by R1. So now instead of R equivalent, I am writing this one. Then you simplify this one, you will get a, what is I1. So according to current division rule, the current through this particular resistor I1 is R1 is total current I. So this is the total current I divided by total resistance, that is R1 plus R2. It is not R equivalent, it is sum of the resistance R1 plus R2 into the other resistance. So if I want to find the current through this resistance R1, I have to write R2. So I1 is equal to total current divided by R1 plus R2 into this R2. Similarly, to find the current through resistor R2, I have to write total current divided by sum of the resistance into this R1, the other resistance. So in voltage division rule, we will use the same resistance, whereas in current division rule, we have to use the other resistance. So the power in a parallel resistance is given by, you can directly add the powers. So V square by R1 plus V square by R2. So we have taken V because V is common for all the resistors. Now let us see some example for resistance in parallel. So here two resistors are parallel and each have the same value. Now let us find what is I1 and I2. So before that, let us find what is the R equivalent. So 1 by R equivalent equal to 1 by R1 plus 1 by R2. So 1 by 10 is 0.1. 1 by 10 is 0.1. So R equal, see this is 0.2 is equal to 1 by R equivalent. You have to find R equivalent is 1 by 0.2 equal to 5 ohms. So most of the students do mistake here. They will find 1 by R equivalent and write the value as R equivalent equal to 0.2 ohms. That is different. Whatever you find here is 1 by R equivalent. So you have to find the reciprocal of this one to find R equivalent. And you can see one thing here. Two resistance, when they are connected in parallel, it becomes, what is the equivalent resistance? 5 ohms. So 10 ohms, when they are connected in parallel, it becomes 5 ohms. It means that when the resistance are equal, it gets divided by 2. Suppose if I have 5 resistance in parallel, all 10 ohms, what will be my equivalent resistance? R by 5, that is 10 by 5, that is equal to 2 ohms. Suppose if I have 10 resistance in parallel, what will happen? 10 ohms divided by 10, so it is 1 ohms. So these are some tricks which you can follow to save your time during exam. No need to find the R equivalent if you have same equal resistance connected in parallel. Okay. So if you see here two 10 ohms are connected in parallel, directly write R equivalent equal to 5 ohms because it will be always R by 2. If I have 3 resistance, it will be R by 3. So what is I1? That is equal to V by R. Always remember Ohm's law. It will be valid. Okay. I1 equal to V divided by R1. So total voltage is 100. R1 is 10. So it is 10 amps. All the resistance are equal. So the current will be equal. So I1 equal to I2 equal to 10. So total current will be 20 amps is coming from the circuit. It gets divided equally to 10 amps and 10 amps because the resistance are equal. Let us take the second example where you have different resistance value. So in this case, you find R equivalent. So 1 by 10 plus 1 by 20. So you find the R equivalent is coming around 6.6 ohms. So what is I1? So V by R1, and you see I2, it is coming 5 amps. So smaller resistance takes more current, higher resistance takes less current. You can apply current division rule also and find the current. Now let us see what is the difference between series and parallel resistance circuit. So I have taken three resistance of different values, 10, 5 ohm and 2 ohms. So R equivalent in this case is sum of all the resistance in a series circuit. So add it, you will get 17 ohms. Whereas in a parallel circuit, R equivalent will be 1 by R1 plus 1 by R2 plus 1 by R3. So that comes around 0.8. So R equivalent is 1.25 ohms. You see here, when the resistance are series, you have higher resistance. When you connect something in parallel, the resistance will get reduced. And you have to see one more thing, that the total resistance will be. So in this case, the total resistance is 1.25 ohms. You see here three resistance, 10 ohm, 5 ohm and 2 ohm. Which is the smallest resistance here? 2 ohms. So in a parallel circuit, the R equivalent will be always less than this 2 ohms. Okay. So whatever is the minimum value or the smallest resistance here is 2 ohms. Your R equivalent will be less than this 2 ohms. So you can verify your answer like this. So now there is a question to be solved by you. So two resistance give combined resistance of 4.5 ohms when they are in series. Okay, so when two are in series, R1 and R2, the total equivalent resistance is 4.5 ohms. And 1 ohm when they are in parallel. So when they are connected in parallel, they give 1 ohms. So you have to find what is the value of R1 and R2. And there are 4 options given. You choose the correct option and give it in the comment section. See, if you try to solve this equation, it will be a bit complicated one. So you learn how to discard the um, incorrect answers, so that you will find what is the correct option here. So take it as a challenge for yourself and find, because these type of questions you will get in competitive exams. It is very easy to find out. So though it appears to be complicated, but it is very easy. You take it as a challenge and try. Now let us see the difference between series and parallel circuit. So circuit in series circuit, all will be connected in series. In parallel circuit, all are in parallel. So what is the voltage here? It gets divided. The total voltage gets divided. So it is equal to sum of the voltages. Here the voltage across each resistance will be same. In case of a current, the current is same in a series circuit, whereas the current gets divided in a parallel circuit. Resistance, if you take R equivalent is equal to sum of the resistance. In a parallel circuit, resistance will be 1 by R1 plus 1 by R2 plus 1 by R3. In addition, we know that whenever is a break or open here, series circuit will not work, whereas a parallel circuit will work in that case. So if you need the study material for this one, you can visit this website, and if you like the video, do subscribe to this Read Electric Vehicle channel. These are some of the references.